For this problem, we're being asked to consider a triangle and then calculate some things. Well, first, let's have a look at what we get given. PQ being equal to 27.2 centimeters. Well, we can call that small r because the vertex r is opposite it. And then we'll call this Q, and then we'll call this P. It's part of our given information, 73.2 centimeters. That's side QR. And then angle P obviously has a value of 132 degrees. So first things first, calculate the size of angle R. Well, for that, let's have a look. We have an angle side pair that's opposite. So, well, jump straight into the sine rule for that one, which just, what do we need though? Because the way we formulate it is always what you want over what you have, because we want this angle. So we'll state it in the form sine of angle R over side R being equal to, well, sine of angle P over P. So, well, that's what we want. What did we have? Well, that is going to be 27.2, and that is equal to sine of 132 degrees over, well, P was 73.2. Therefore, sine of R is just going to equal 27.2 times sine of 132 degrees, all divided by 73.2. Thusly, angle R is equal to, well, inverse sine, and then we'll apply it to this value. Because our calculators are so nice, we get to type this in as is. Ooh, I think I'm out of bounds in terms of my screen real estate, so let's just bring that a bit closer. So that's sine of 132. Still out of bounds. Now, anything worth doing is probably worth doing, right? So again, that's inverse sine. So it's 27.2 sine of 132 degrees, everything divided by 73.2. The reason I'm doing it that way is because that's what you punch into the calculator. No rounding, as you'll notice. And what we'll get is something like 16.03, blah, blah, blah. But our trigonometry section normally allows us to round off to one decimal value, and in this case, it happens to go to 16.0 degrees, or just 16 degrees. So that's fine. We now have this value over here. The next thing they want is for us to calculate the area of triangle PQR, or the entire triangle. Now, we can use the area rule if we had PR. That way we could have used this angle, or we could have used that angle. However, if we happen to calculate angle Q, then we can use our existing sides without the need for calculating side Q or side PR, whichever you choose. So angle Q, basic calculation is just 180 minus 132 plus 16 degrees in brackets, and that'll render angle Q to be 32 degrees. Remember, this is going to be angles in a triangle. Right, so how do we apply the sine rule? Well, the area of triangle PQR is going to be equal to 1/2 of, well, R times P times sine of angle Q, which just looks like this, 1/2 of 27.2 times 73.2 times sine of 32 degrees, and that should give us, if my calculator spoke the truth, if it could speak, 522.5 square centimeters. And that is as good as that gets. Well, how about our final one for this specific video? Well, we have a figure where we have angle SPQ being given the parameter A, PQS being given the parameter B, and then PQ being given the parameter H, SR, and PQ are perpendicular to RQ. Well, so that bit's obvious, which is nice, which means we can transcribe that angle over here. That means that angle is also equal to B, which is RSQ. I think that's about the size of that information for this triangle. And then, well, given that this is 3D trig, might as well do that over there. Now let's see. Determine the distance SQ in terms of A, B, and H. Well, SQ is what we want, and we have a known value over there at that vertex P, and then we have H, and then at angle PSQ we've got this, which we just calculated. Now given that it's 3 marks and we now have a known set over there, angle and side, might as well use that. But remember, it's always going to be what you want over what you have. So SQ is what we want, and then it's over sine of A, and then PQ is what we have, which is H, and then it's going to be sine of, well, 180 degrees minus A plus B. So let's see where this takes us. Well, that means SQ is going to be equal to H times sine of A. And at the bottom we can do a reduction. Sine is positive in the second quadrant because it says 180 minus over there between brackets. So that's just going to be sine of A plus B. Well, and that's exactly what they want. So now they need us to show that RS is equal to H times sine of A, cosine B, sine of A plus B as the denominator over there. So for that specific 3.3.2, well, where's RS? Well, that's RS over there, and it's in the triangle adjacent. But we already have SQ, and as we said, that angle over there, RSQ, is going to equal B. Why? Because we have alt angles, and RS ends up being parallel to QB. So for this we can have a look. Well, RS and SQ are going to be useful if we use the cosine ratio, so let's do that. So cosine of B is just going to equal RS over SQ. For RS, if we multiply both sides by SQ, it's going to be equal to SQ times cosine of B, but we have a term for SQ which is equal to, well, H sine of A over sine of A plus B, and then we just need to multiply it by cosine B, and there, everything's been proven, and I close the bracket in the denominator as a final touch. So yeah, that finishes that.